Lesson: Text classification and clustering. Text classification and clustering are fundamental techniques in natural language processing that significantly enhance cybersecurity measures. Effective text classification allows for the automated categorization of textual data into predefined classes, while text clustering groups similar texts together without predefined labels. These methodologies are instrumental in identifying and mitigating cyber threats, improving threat intelligence, and refining security protocols. Text classification entails the process of assigning predefined labels to a document based on its content. This process can be supervised or unsupervised. Supervised classification relies on labeled training data, where the algorithm learns to predict the class of new data based on patterns identified in the training set. Common algorithms include naive Bayes, support vector machines, and neural networks. The efficacy of these models is significantly enhanced by feature extraction techniques such as term frequency inverse document frequency and word embeddings like word2vec and glove. In the realm of cybersecurity, text classification is employed in spam detection, phishing email identification, and malware classification. For instance, research has demonstrated that SVM classifiers, when combined with TF-IDF features, achieve high accuracy in detecting spam emails. Similarly, machine learning models trained on large datasets of phishing emails can identify new phishing attempts with remarkable precision, thereby protecting users from potential breaches. The classification process begins with pre-processing steps such as tokenization, stemming, and lemmatization to normalize the text. This is followed by feature extraction, where meaningful representations of the text are generated. The choice of features is crucial as it directly impacts the model's performance. TF-IDF, which measures the importance of a word in a document relative to a corpus, is particularly useful for distinguishing relevant terms in cybersecurity texts. Word embeddings, on the other hand, capture semantic relationships between words, enabling more nuanced text representations. Once features are extracted, the classifier is trained on labeled data. During training, the algorithm learns to associate features with corresponding labels. Evaluation metrics such as accuracy, precision, recall, and F1 score are used to assess the model's performance. High-performing models are then deployed to classify new, unseen data, continuously improving through feedback loops and updates. In contrast, text clustering involves grouping similar documents together without prior knowledge of their categories. This unsupervised learning technique is particularly useful for exploratory data analysis and anomaly detection in cybersecurity. Clustering algorithms like k-means, hierarchical clustering, and dbScan are commonly used. K-means, for example, partitions data into k-clusters by minimizing the variance within each cluster, while dbScan identifies dense regions of data points, effectively detecting outliers. Clustering is invaluable in cybersecurity for identifying patterns and anomalies in large datasets. For instance, clustering can be used to group similar security logs, facilitating the detection of unusual activities that may indicate a security breach. A study by Xu et al. Demonstrated the effectiveness of clustering algorithms in identifying network intrusion patterns, thereby enhancing threat detection and response capabilities. The clustering process begins with the selection of an appropriate algorithm and the determination of the number of clusters or other parameters, such as the epsilon parameter in dbScan. Pre-processing steps similar to those in classification are applied to the text data. Feature extraction techniques like TF-IDF and word embeddings are also used to represent the texts numerically. The chosen clustering algorithm then partitions the data based on the defined criteria, revealing hidden structures and relationships within the data. Evaluating clustering results is challenging due to the lack of predefined labels. Metrics such as silhouette score, Davies-Bouldin index, and visual inspection of cluster plots are used to assess the quality of the clusters. High-quality clusters exhibit high intracluster similarity and low intercluster similarity, indicating that the algorithm has effectively grouped similar documents together. Combining text classification and clustering can yield powerful solutions for cybersecurity. For instance, initial clustering can be used to explore and label data, which can then serve as training data for supervised classification models. This hybrid approach leverages the strengths of both techniques, enhancing the overall performance of cybersecurity systems. The integration of text classification and clustering into cybersecurity frameworks requires careful consideration of data quality, algorithm selection, and evaluation metrics. High-quality, representative data is essential for training robust models. Algorithm selection should be based on the specific characteristics of the data and the desired outcome. Evaluation metrics must be chosen to accurately reflect the performance of the models, guiding continuous improvements. Moreover, the deployment of these models in real-world cybersecurity applications necessitates ongoing monitoring and updating to adapt to evolving threats. Automated feedback loops, where the models learn from new data and adjust their predictions accordingly, are crucial for maintaining high levels of accuracy and relevance. Possible. Recent advancements in deep learning have further enhanced the capabilities of text classification and clustering in cybersecurity. Convolutional neural networks and recurrent neural networks, particularly long short-term memory networks, have shown remarkable success in capturing complex patterns in textual data. These models, when trained on large datasets, can achieve state-of-the-art performance in various NLP tasks. For example, CNNs have been used to detect malicious URLs by analyzing the text content of web pages, achieving higher accuracy than traditional machine learning models. Similarly, LSTM networks have been employed to classify malware based on code analysis, demonstrating superior performance in identifying new and evolving threats. The integration of text classification and clustering with deep learning techniques offers significant potential for enhancing cybersecurity measures. These advanced models can process vast amounts of data, identify intricate patterns, and adapt to new threats with minimal human intervention. However, their implementation requires substantial computational resources and expertise, underscoring the need for continuous research and development in this field. In conclusion, text classification and clustering are indispensable tools in the arsenal of cybersecurity professionals. These techniques enable the automated analysis of textual data, facilitating the detection and mitigation of cyber threats. By leveraging machine learning and deep learning algorithms, cybersecurity systems can achieve higher accuracy, efficiency, and adaptability. The ongoing advancements in NLP and AI hold promise for further enhancing the effectiveness of these techniques, paving the way for more robust and resilient cybersecurity solutions.